All right, welcome to the Explainer. Today we're diving into something every single Python dev has to face, the technical interview. Yeah, it can feel like this impossible gauntlet, right? But stick with me because we're about to give you the keys to basically crack it wide open. So let's just start right there. I mean, this isn't just about memorizing answers to pass some test. This is about actually getting better. It's about leveling up your game. So you gotta ask yourself, are you ready to really elevate your Python skills? Because that's the journey we're starting right now. Okay, so what is it? What's the secret sauce that separates a good Python developer from a truly great one? Especially when you're in that interview chair and the pressure's on. Look, it's not just about knowing the syntax. Anyone can learn that. The real difference is how deep your understanding goes. And that's exactly what we're going to unpack. All right, first up, the fundamentals. Think of this as the first stage of that interview gauntlet. These are the non-negotiables, the absolute bedrock of your Python knowledge. You can bet that any interviewer, and I mean any interviewer, is going to expect you to have this stuff down cold. No excuses. So let's kick things off with a total classic, lists versus tuples. The number one thing an interviewer's listening for here is one word, mutability. It's that simple. Lists are mutable. You can change them, add to them, remove from them after you've made them. Tuples, they're immutable. Once you create one, it's locked in. You can't change it. So why does this matter so much? Well, it's not just a trivial question. It shows them how you think about data. If you've got a collection of items that should never change, a tuple is your best friend. It's safer for sure, but it's also faster. And explaining that trade-off, that's gold in an interview. And then there's the pass statement. It's kind of funny, right? It literally does nothing, but it's one of the most useful nothing statements you'll ever use. Think of it as a placeholder. You're sketching out your code. Maybe you know you need a function or a class here, but you haven't written the logic yet. Well, you can't just leave it empty. Python will throw an error. So you just drop in pass, and everything runs smoothly. It's like saying, I'll come back to this later. And it's perfect for building out the whole structure of your application before you dive into the nitty-gritty. Okay, a quick one, but this is huge. PEP 8. Seriously, don't forget it. This is the official style guide for Python. And knowing it, it's just non-negotiable. Here's why. Anybody can hack together some code that runs, but a real professional, writes code that other humans can actually read and understand. Following PEP 8 tells an interviewer that you get it. It says you can be a good teammate and that you build things to last. Okay, so once you've got those fundamentals locked down, we start climbing the ladder. Now we're getting into the core building blocks of Python. This is the stuff you'll be using day in and day out in a junior or mid-level role. These are the concepts that really let you write clean, powerful, and efficient Python code. All right, decorators, I know. They can feel like some kind of dark magic at first. But trust me, they're surprisingly straightforward once you see the pattern. Just think of it like this. First, a decorator is just a function that eats another function. It takes a function as its input, then it adds some new bells and whistles to it, kind of wrapping it in new functionality, and finally, it spits out the new improved function. The beauty of this is you can add features, like logging or timing, without ever changing a single line of the original function's code. And nailing this in an interview, it shows you get that in Python, functions are first-class citizens. So let me throw a scenario at you, one that comes up all the time. You're writing a function, right? But you have no idea how many arguments someone is going to pass into it. Is it going to be 2, 5, 20? How on earth do you build a function that can handle all of that without breaking? This is a super common interview problem, and it's all about testing how you think about flexibility. And the answer is args and double quargs. You've seen them everywhere. They're Python's elegant solution to this exact problem. The args, with the single star, hoovers up all the positional arguments you pass in and bundles them into a tuple. The double quars, with the double star, does the same thing but for keyword arguments and puts them into a dictionary. Once you master these two, you can write some ridiculously flexible and reusable functions. It's a game changer. Oh, and here's another classic trip-up. The difference between append and extend. This one gets people all the time. If you take a list and you append another list to it, say 3, 4, it sticks that entire list on the end as a single item. So you get a list inside your list. But if you use extend with that same 3, 4, it takes each item from that list individually and adds them. The result is one flat list. It's a subtle point, but so important. Basically, append one thing, extend with many things from an iterable. Okay, time to go deep. We're now diving into the Python internals. This is the stuff for senior and expert level roles. Getting these questions right shows that you don't just use Python, you truly understand it. You know what's happening under the hood. And honestly, this is the knowledge that separates a mid-level dev from a real senior candidate. Let's talk about the big one, the GIL, the Global Interpreter Lock. If you're going for a senior role, you will be asked about this. So what is it? At its heart, the GIL is a mutex, a lock, that basically says only one thread can be running Python bytecode at a time. I love the analogy of an engine room. Imagine the Python interpreter is the engine room, and there's only one key. You might have a dozen crew members, your threads, all ready to work, but only the one person who holds the key can go inside and actually run the engine. That's the GIL in a nutshell. Okay, so right about now you're probably thinking, wait a minute, if only one thread can run at a time, what's the point of even using threads? Why do people call the GIL a problem? And that right there is the million-dollar question. That's exactly what a good interviewer wants to hear you talk about. And the answer, like so many things in programming, is it depends. It depends entirely on what your code is doing. If you have a CPU-bound task, something that's just pure number crunching, then yes, the GIL is a huge bottleneck. Your threads can't truly run in parallel, so you get no speed up. The workaround? Use the multiprocessing module. You fire up completely separate processes, each with its own interpreter, and you totally sidestep the GIL. But for an I/O-bound task, where your code is just sitting around waiting for a network request to come back or a file to be read, Python is smart. It releases the GIL during that waiting period. And that's where threading and asynchronous are still incredibly useful, because one thread can go do other work while another one is just waiting. And let's quickly talk about memory management. Look, one of the joys of Python is you don't have to manage memory by hand, right? But a senior dev needs to know what's going on. So, real quick, Python has a private heap where it stores all your objects. Its main strategy is something called reference counting. Every object keeps track of how many things are pointing to it. As soon as that counter hits 0, poof, the object and its memory are gone. But what if you have objects that point to each other in a circle? The count will never hit 0. Well, that's what the garbage collector is for. It's a backup system that swoops in and cleans up those tricky circular references. So we've gone from the very basics all the way down into the deep, dark internals of Python. But the last step, the thing that takes you from just good to guru status, it isn't about memorizing a list of facts. It's about a mindset. It's about knowing how to think like a top-tier developer. So let's put a bow on this. What is that guru mindset? Well, it's a checklist. 1, master your data structures. Know your lists, your tuples, your dicts inside and out. 2, always explain the why. Don't just do something, explain why it's the right choice. 3, talk about the trade-offs, performance versus mutability, memory versus speed. 4, understand the guts of Python, the GIL, memory management. And finally, above all else, write clean, readable PEP 8 code. You bring that mindset into an interview, and I guarantee you will stand out. Look, we've covered the what and we've covered the why. You've got the concepts now, you've got the tools. But remember, the interview, that's just a door. It's not the destination. The real test, and frankly, the real fun, is everything that comes after you walk through it. So the only question I have left for you is, what are you going to build?